Hey guys, so today we're going to be doing a tutorial on the power rule. So we'll be going over some practice questions. If you're looking for an explanation of the concept of the power rule, a derivation, and basically just an introduction to it, then I'll refer you to the video on just the power rule. In this video, we'll be doing examples using the power rule and the sum and difference rules. So let's get started. So our first example is fairly easy and should be familiar if you watch the power rule video. So we're given a function f of x, and that is equal to 5 root x plus 6x squared plus 1. And we're asked to find the derivative of this function. So we're looking for f prime of x. So let's get started. Let's write down our function again. So we got 5, and we want to write it in a more you could say workable format, something easier to work with. So what we're going to do is that we're going to convert this square root into an exponent. So this is x to the half, and this is plus 6x squared plus 1. So this looks like a easier format to work with. So let's take the derivative. So f prime of x is just, so each component, take the derivative of each component or each term. And so our first term, we bring down the half. So we got 5 over 2 x, and then, half minus 1, which is negative half. Okay, that's our first term. Now let's move on to our second term. So let's take the derivative of this, bring down the 2. What's 6 times 2? It's 12. So we got 12x. 2 minus 1 is 1. So, and then the last term, the derivative of a constant is just 0. So just plus 0. So it just comes down to 5 over 2 x to the negative half plus 12x. You could simplify this if you want. On tests, professors and teachers won't ask you to simplify derivatives because you only have that much time, such a limited amount of time. So you could if you wanted to. If you're looking for slopes of tangent lines and you got this really big expression, it's often easier just to simplify and then plug in numbers to find slopes, because you're, I guess, less likely to make mistakes or miscalculations, and it's just cleaner overall. So let's go on to our second example. So our second example gives us a function f of u is equal to 2u plus 3 u plus 1. So and it asks us to find f prime of u. So here we see this is a function of u. So we don't see any x's. We're usually used to seeing x and y, but here we're given a function of u and we're asked to find the derivative with respect to u. So we just basically, since we're given a function of u and we're asked to find the derivative with respect to u, well, this is no different than when we take the derivative of some function f of x, which is some function of x, and we take the derivative with respect to x, right? This is no different. If we were to take the derivative with respect to x of f of u, it would turn out to be 0, actually, because there are no x's in the equation. F of u doesn't depend on x, and neither does its derivative. So here we're asked to find the derivative with respect to u. So in a way, we could treat u as we treated x when we took the derivative with respect to x when there was a function of x. So now that we've cleared that up, let's try to take the derivative. But before we do that, I'm going to show you what not to do, what you're not going to do. You're not going to take the derivative of each binomial and multiply it together. That is wrong. F prime of u is not 2 times 1. It's not 2. You are not going to do that. You do not take the derivative of each binomial and multiply it together. That's not the correct way. So let me show you how it's really done. So we have our function. Actually, I'm going to erase this. I'll write down our function again. So we got f of u, and that is 2u plus 3u plus 1. So let's what we can do is actually multiply this out, you know. So what do we end up with? 2u squared plus 2u plus 3u plus 3. So, you know, clean this up a bit. 2u squared plus 5u plus 3. So what we did is that we FOILed this out to make it look like a more, you know, get it into a more workable format, you know, something that we're more familiar with when we were using the power rule. So now that we've gotten into that form, it's quite easy to take the derivative. So let's do that. Let's take the derivative with respect to u. So what is it? Well, that's 4u plus 5, and then the derivative of a constant is just 0, so plus 0, so f prime of u is just 4u plus 5. So it's good not to make that mistake I showed you guys earlier. That would be completely wrong. So beware of that. And so let's move on to our next example. So example 3. So this example says find the slope of the tangent line of the function f of t is equal to t squared plus 1 over t squared at the point 1, 2. So again, we are going to write out our function. We got our function here, and we want to get this into a more, you know, a more workable format. So t squared, that's fine. We can use the power rule and take the derivative, but our second term, what we can do is we can say this is t to the negative 2. Because, well, these two are equivalent. So if you know your exponents well, you can make this, you know, realization that you can convert this into this and write it with an exponent, with a negative exponent. So again, you got to have, you know, strong pre-calc skills, and you got to be able to make these realizations and connections. Otherwise, you know, you might not be able to answer a question. So let's take the derivative now that it's in a much easier format to work with. So we got f prime of t, the first term, fairly easy. We got 2t, and our second term, we bring down the negative 2, so negative 2t, and it's negative 2 minus 1, which is negative 3. Let me rewrite that. Negative 3. So there we go, we got our derivative. Now we want to find the slope of the tangent line, and recall that the derivative gives us the slope of the tangent line upon some input. So our input here, our point at which we want to find the tangent line at f of t, is 1, 2. So let's do that. Let's plug in t is equal to 1 because this corresponds to our t values. So t is equal to 1, so 2 times 1 minus 2, 1 to the negative 3, and this just comes out to 0 because, you know, the ones are basically unaffected by the exponent, so it's 2 times 1 minus 2 times 1, basically, so that's just 0. So the slope of our tangent line is 0. So you need to get used to having functions where you're not seeing, you know, x's and y's, and you're seeing other variables, and you need to make those connections. That's basically the logic behind how you know, write a function. Here, it's a function of t. F of t is a function of t. Depends on t. So what we traditionally would recall, you know, the x-axis and the y-axis, well, t would be plotted on the x-axis here. So get used to that. because you're not always going to be working with, x and y. So you need to get used to these different, you're not just going to be seeing x and y. You could be seeing t's, w's, q's, but you need to understand the logic and not get, messed up with just the concentrating on the letters. They're the variables. So let's go on to our next example. Our next example is just asking us to take the derivative of this function f of u, just given to us. So we're just finding f prime of u. So that's pretty straightforward, but we got a decently large function here. So let's get started. So what we can see initially is that we can, in this first term, we can FOIL this out. We can distribute this out, multiply it out. So let's do that. Let's write f of u. F of u, we distribute this out, is 4u squared plus u plus 12u plus 3 all over 2. And if you look at the second term, we can actually simplify this as well. So going back to your exponent rules and exponent laws, this comes out to, you can see there's a cancellation a bit. This will just come out to negative 1/2. If you know your pre-calc, if you have good pre-calc skills, you can make this realization quite quickly. So like I said, it's very important to have strong, algebra skills so you can make these connections instantly. So in this case, let me just explain this. So we got u to the half all over u. Well, you got these exponents dividing, so you can basically minus the exponent. So this is just a 1. So what we are left with is 5 over u to the half, which is the square root of u. And well, if I want to write this in a, you could say, more workable format so we can use the power rule, it would just be this. So that's just a side note. And let's continue on with the question. So let's simplify this a little more. What does this come out to? Well, we'll divide each term by 2. So our first term is just going to come out to 2u squared. Our second term, because this adds up to 13u, is just going to be 13 and then this 2 divided by 2, u. And the last term is just going to be 3 over 2. And we're going to have our second term right here, or actually in this case our fourth term, just u to the negative half. So now this isn't anything special. So let's take the derivative, take the derivative of each component. Our first is going to be 4u, because you bring down the 2 and you multiply, you got a 2 here, so that comes out to 4u. Now plus 13 over 2, because you bring down this 1 that we don't usually write, and 1 minus 1, because you minus the exponent up here, that comes out to 0, so it'll be u to the 0, which is just 1. The derivative of a constant is 0, so we just add 0. And here we have, bringing down the half, the negative half, we get negative 5 over 2, u to the negative 3 over 2, because negative half minus 1 is negative 3 over 2. So overall, we just come down to this. 4u over 13 divided by 2 minus 5 over 2u to the negative 3 over 2. So again, the pre-calc skills, you'll be able to see these relationships, and knowing how to use the power rule, you need to sometimes expand polynomials, see cancellations like this, and use your exponent laws. So there's a lot of rewriting that you sometimes have to do before you can actually take the derivative. So let's move on to our next example. So I'll do another video with more examples on the power rule. second part to this tutorial, I suppose. So this question, it asks us to find the equation of a tangent line. Find the equation of the tangent line to the function. I'm going to say this is, let's say W. Actually, hold on. The function. I'm going to say this is W is equal to t cubed plus t root t plus t over t cubed. And you can say this is a function of t, so you could also call this f of t. Doesn't matter. W is equal to f of t is equal to this. So let's simplify this a bit. We can call this W. And our first term, nothing really to simplify. Our second term, well, using our exponent rules, we can see that this collapses down to just t to the 3 over 2, because we got a multiplication, so we add the terms. So, and our last one, we just cancel that, and we just get t to the negative 2, actually. So we get t to the negative 2 because, well, these cancel, and then you're left with 1 over t squared, and we can actually convert that to just t to the negative 2. So now we got a pretty easy to format to work with. Now let's take the derivative. So our derivative, which we say w prime, is 3t squared plus 3 over 2t to the half, because we minus 1 from 3 over 2, minus 2t to the negative 3. So that's our derivative. And oh, I forgot to write the point at which we're finding the derivative. And the point at which we're finding it is 1, 3. So the derivative, recall, gives us the slope of the tangent line. So what do? We plug in the point, well, we plug in 1 for t. So what do we get? We get w prime, which is equal to the slope of the tangent line, is 3 times 1 plus 3 over 2 times 1 to the half minus 2 times 1 to the negative 3. And basically, 1 to the power of anything is just 1. So this just comes down to 3 plus 3 over 2 minus 2. And this is just 5 over 2. We like to write our answers in fractions in calculus because it's neater and cleaner than using decimals. Sometimes if you're writing decimals, you might make a point, like in this case 2.5, and it might be too faint to see, especially on paper. So to avoid that, we just we write things as fractions, and it's just much cleaner to look at. It makes your work much cleaner. So now that we have the slope, I'm going to erase all this. I'm just going to find the tangent line now. So we have the slope, and in this case, we always write a line as y equals mx plus b, but here we're dealing with w being a function of t. So in this case, we'll have w is equal to mt plus b, because this is you can imagine this to be a graph where t is on the x-axis and w is on the y-axis. So our tangent line is going to be w equals mt plus b. So since our slope is 5 over 2 and our point is 1, 3, We're going to have 3 is equal to 5 over 2, plug in 1 for t, plus b. B just comes out to be a half. So our tangent line, the equation of our tangent line is w is equal to 5 over 2t plus a half. Not too hard. On the next tutorial, I'm thinking of, picking even more harder examples to work through. So tune into that if you're looking for maybe, more practice. The key to this is to understand what the derivative means and do a lot of practice, taking derivatives and, working on those, using those pre-calc skills that you've built in the past to really, take advantage of, because there's a lot of rewriting that sometimes has to take place for you to take the derivative. Some of that becomes, I guess, unnecessary once you get into, we get into more and more derivative rules. So for now, rewriting is important. So make sure you got those strong pre-calc skills and you have strong understanding of your pre-calc concepts.